Hello and welcome. This is an Algebra 1 video, and our topic is evaluating algebraic expressions. Also, this is a quarter 1 topic. So if I look at the directions, I see evaluate each expression with the given replacement values. And of course, this when is a typo, so I'll cross it off. And then it says leave all non-integer answers as fully simplified fractions. So if your answer is a fraction, please do not convert it to a decimal. Fractions should remain and they should be simplified. So one of the highlights when I look at number 1, I've got replacement values of a equals 3, b equals 4, and c equals -2. When I have a negative number, it's really important to start getting into the habit of substituting that negative number in parentheses. And the reason really applies to the idea of exponents, and in particular, even exponents. So let's take a look at this. -4 squared. By putting the parentheses around the -4, this exponent now applies to the entirety of this -4. It really is saying -4 squared, or in the expanded form, -4 times -4. I know that a positive times a positive is, a negative times a negative is positive. I was getting really positive there for a sec. Negative times negative, positive, and 4 times 4 is 16. Here is what happens if I don't use parentheses. If I have -4 squared, without the parentheses, my exponent is attached to the 4 only. This negative is really saying the opposite of 4 squared. Let's just kind of take a step back to just negative x. I know that negative x is really -1 times x. So I'm going to expand this using this negative as a -1, because I think this really highlights what's happening here without the parentheses. This negative is off on its own, and the square only goes with the 4. So now I have -1 times 4 squared, which is 16, and a negative times a positive is negative, and it's 16. So using those parentheses literally makes the difference between a 16 all the way to a -16. It's really important. And I think if you get in the habit of it early, you don't make mistakes later on when you see many more exponents. Okay, number 1 says, in parentheses, 2a squared divided by b times c. So let's substitute our replacement values. I have 2 times a, which is 3, squared, divided by b, which is 4, times c, and I will put that -2 in parentheses just to make sure that nothing incorrect happens. Now, I've got GEMDAS. I've got to think about my order of operations in order to evaluate these expressions. G stands for all grouping symbols. E stands for exponents. Multiplication and division is on the same line because I am going to evaluate left to right and left to right addition subtraction. So if I look here, I see parentheses around the 2 times 3 and parentheses around the -2. This is an instance where those parentheses aren't going to change my answer mathematically, but it is a nice reminder that, hey, this 2 is negative, so you will be using the integer operation rules. So in parentheses here, I have 2 times 3. 2 times 3 is a positive 6, so I can drop the parentheses, and now I have 6 squared divided by 4 times -2. I'll look back at these parentheses and remind myself, hey, it's just a -2 in there. There's no operation to perform. So I'm going to move on and look for an exponent. And indeed, I do have 6 squared, which is 6 times 6, not 6 times 2. It's 6 times 6, which is 36, divided by 4 times -2. Alrighty, do I have multiplication and division? I actually have division and multiplication. Remember, even though m comes first, I'm left to right, just like reading a book. So I will evaluate 36 divided by 4 first. That's 9 times -2. My last step is a positive times a negative, which is negative, and 9 times 2 is 18. So evaluated with these replacement values, that expression is -18. Let's look at number 2. When I look at number 2, I have a positive and a negative. I'm going to substitute that in with parentheses. A 5 right next to a variable indicates multiplication. So I have 5 times a squared, 3 squared, plus b squared. It's negative, so I'm going to make sure I put the parentheses. Now I have a really long fraction bar here to start with, right? And I have 4. If there's nothing in between a parenthesis and a number, again, that is an implied multiplication. And I have 6 minus negative 3. It's a very common error to just say, oh, it's subtraction. That takes the place of the negative 3. Well, it doesn't. You are going to have the negative. So if I look back at GEMDAS, I do have I have a couple grouping symbols. The first one that's really important is this long fraction bar where I have expression operations to perform on the top and on the bottom. I will completely evaluate every operation in the numerator and every operation in the denominator, and then see what type of answer I have. So let's do step 1 in the numerator. The only parentheses are around this negative 3. Nothing to happen, nothing to do inside the parentheses. But I have an exponent here and an exponent here. So 5 times remains, and I have 3 squared, which is 3 times 3, 9, plus, because it's in parentheses, remember, it's negative 3 times negative 3, which is 9. I take it step by step, numerator, then denominator. In the denominator, I have 6 minus 3 in parentheses. You may remember the idea of keep, change, or adding the opposite. So if you keep, change, you keep the 6, you change the subtraction to addition, and you change the negative 3 to its opposite, positive 3. So really, I still have 4 times, and I have 6, keep, change, plus 3, which is 9. All right, let's look at step 2 in our numerator. No exponents, I've got multiplication. That's going to be 45. 5 times 9, and I still have the plus 9. And in the denominator, I only have one step left. 4 times 9 is 36. I have one final step. 45 plus 9 is 54 over 36. This is a good answer, but it is not a full credit answer. What you are missing here is you're missing a simplified fraction. You might be tempted to put into your calculator 54 divided by 36. You're going to get 1.5. And if you can easily convert 1.5 into 3 halves, that is fine. But if you can't, you need to simplify this by trying to find the greatest common factor. Now, the greatest common factor is the number that will evenly go into 36 and 54. Both of them. It's 18, but maybe you don't see 18. So let's just notice that 54 and 36 are even numbers. So I'm going to divide the numerator by 2, divide the denominator by 2. 54 divided by 2 is 27. 36 divided by 2 is 18. I don't have 2 even numbers. And I could say, does 3. Sometimes you just start right at the next number. So 2 doesn't work, does 3. But 27 is one of my particular favorites. I know 9 goes into 27. I don't know why I like it so much, but I know 27 divided by 9 is 3. And actually 18. 9 goes into 18. 9 is a factor of 18. So I'm going to divide by 9 right here. Again, 27 divided by 9 is 3. 18 divided by 9 is 2. And here's that 1.5, 3 halves. And this is your final fully simplified fraction answer. Okay, we're going to get to number 3 and 4 in this video. Let's take a look at number 3. I've got a long fraction bar, so I know I'm going to do some evaluating in the numerator. And I've got this symbol. You don't remember it. It's called a square root or a radical. Let's substitute no negative numbers, so I just have 3 plus 4 squared in the numerator over the square root of b, which is 4. All right, numerator, denominator, we'll figure it out. Grouping symbols. 3 plus 4 is in parentheses. I must do that first, so it is going to be 7. That's positive, don't have to keep the parentheses, squared. Square roots are a grouping symbol, so it is the only step, but if there were other things, it would be the first step. The square root of 4. What number multiplied by itself equals 4? Well, 1 times 1, nope. 2 times 2. 2 times 2 equals 4, so the square root of 4 is 2. I have only one thing to do here. I've got an exponent. 7 squared is 7 times 7. That's 49. And there's nothing left in the denominator. I have 49 over 2. Now you might be tempted to turn this into a mixed number. That is absolutely okay, but here in Algebra 1, you can leave your answers as improper fractions. Actually, you might have been tempted up here too. You also might think to yourself, oh goodness, 49 over 2, that couldn't possibly be an answer, but indeed it can. This has a spot on the number line. It is the answer. Last one in this video, number 4. Lots of exponents going on. So let's see what we got. We've got 3 times x squared. X is negative 2, so I have to put that into parentheses. Minus 3 times y, which is a negative 3. That is all going to be cubed at the end. So we definitely have things going on in parentheses. But let's see if we have parentheses inside of parentheses. Nope, we just have some negative numbers in parentheses. Okay, exponents inside these parentheses. I have the negative 2 squared. I'm not going to do this 3 squared until the end because it's all inside the parentheses. Negative 2 squared is 4. So I have 3 times 4 minus 3 times negative 3, and it will all be cubed. Multiplication and division. I have 3 times 4, which is 12, minus 3 times negative 3, which is a negative 9, and that will all be cubed. We've got another keep, change, so this is actually 12 plus 9, which is 21 cubed. And we need to put that in your calculator. And that equals 9,261. It might feel maybe uncomfortable having a number that big, but guess what? It works. So that's all for this video. You can look at the next algebraic expression video and to see numbers 5 through 8. Thanks so much.